All right. This is going to be a conceptual talk. There's no challenge associated with it. There's just a bunch of terms and a bunch of concepts that I want to introduce you to that you will need, well, forever in your dev life, but in particular in the next coming weeks. So you are all now polyglot programmers. You can program in multiple languages. And you are working towards becoming backend developers right now, getting into the databases, and then we're going to start looking at how do you code to from an application that interacts with the database. Then you start putting it together. And about a little over a week from now, you will all be full stack developers. So the concepts that I'm going to introduce you to now is going to very much help that process. So we're going to talk about how the internet works from the perspective of a full stack developer. This is in no way a cohesive talk about how the internet works. People get their PhDs in that topic. We're just going to touch on a couple of important topics for the scope of this class. Okay, so basically the internet is it's the largest machine on Earth. I like to use the analogy of like a colony of quaking aspens. You know, there's all these quaking aspens in southern Utah, and people realized that it actually wasn't individual trees. It was all one single species because all of their roots were connected, and it was just different trees that were genetically similar to all the other trees because they were all the same tree, essentially. And so that's kind of how I think about the internet, is that individually we all have our computers and we connect to other individual computers. But underneath all of that is just a bunch of wires that run all the way around the world and connect all of our individual computers. So in the most fundamental way, the internet is a series of tubes that connects servers all over the world. And a server is a computer with all of the user aspects stripped away. So your computer is a server. When you run yarn start on an app, on your Rails or your React app, you are asking your computer to act as a local server. But if something is hosted, meaning that it can be found on the internet with a URL, that content has to be stored somewhere else in the world on another server, or maybe many servers. So if you deploy, if you're using GitHub Pages like you did in Jumpstart, you are asking a particular service to store your code and your database content on their server, and then provide you the pathway to get there in the form of a URL. So kind of the long and the short of the internet from a developer's point of view is a series of requests and responses. So every time you hit enter on a URL or submit a form or post a picture, you are doing a request response cycle. And being in development, being a full stack developer, is creating the code that makes successful cycles. So we'll talk a little bit more about that. All right. Do you see the white screen? Cool. Is there anything blocking it or in the way? Like other stuff on the screen? Okay, beautiful. Great. All right. So what we have here is we have our laptops, our personal computers. And being connected to the internet means that we have access to information that is stored on servers. Servers are just computers with the user aspect stripped away, so it's just a bunch of hard drives. We have our happy little server out here in the world, And if I want information from that server, I go onto the internet and I hit enter on a URL and I send out a request. The request goes and finds the appropriate server. And that server responds with content that's delivered back to my computer. And within this request response cycle, each piece has two additional parts. So there's kind of four main parts of that, two on the request and two on the response. So the request, let me do this down here. So the request has a location and it has an action. The response, I'm sorry?
I'm sorry, are we supposed to see that? I can't see that.
Which part?
Sorry, what you were writing.
At the bottom.
Oh, I see.
At the bottom?
Got it. Yeah, let me see. Can I remove you? Screen?
All right, thank you.
Better? Sweet.
Yeah.
Thanks for pointing that out. Response. All right, so request has location and action. Response has a status and a payload. All right, so we're going to talk about each of these pieces. So let's start on the request. The location is the URL. So when we are looking for a particular piece of information that lives on one particular server somewhere in the world, the way that we find that is, for us, it's ultimately through a URL. The way that the computer actually looks it up is through an IP address. An IP address is a series of numbers that computers read. The URL is the human readable version of that. A lot of the communication that we're doing in development is this back and forth between how computers process information and how humans do. We do not process information very well in series of numbers. Even phone numbers, we break them up into sections because we just don't memorize series of digits very well. It is much easier for us to talk about google.com than it is to talk about 08.08.08.08. Like that doesn't connect to our brains. But and that's kind of a side note as far as like the mapping of an IP address to a URL. But knowing that a URL and an IP address essentially serve the same purpose, one's for computers and one's for humans. And the actual process of going from finding the IP address and what URL connects with that is definitely a much bigger topic that we're not going to cover within the scope of this class, but know that it does actually take some effort on the side of your computer, because there are obviously like billions of different IP addresses. And every time your computer goes to find one, we have to figure out this specific one that maps to the particular server. And that's where your computer will save the locations of places you visit often. Think about it as like, I don't know if anyone's old enough to remember this, but when I was young, we had phone books and you would go look up someone's name in a phone book and find their phone number. And that's kind of the same thing as like an IP address and a URL, right? Because I don't necessarily know the phone number. I work as a human, I'm much better with names. So I can look up a name and then I can find the corresponding phone number that will connect me to that person. But that takes energy to just look through an entire phone book worth of content to find the one person. So if I was calling them often, I would maybe pull that number out and put it into like a shorter directory or a Rolodex that I would keep on hand. And your computer does the same thing, because every time it looks up, it takes a lot of energy and a little bit of time. And so your computer will remember websites you visit often. This is great from a user perspective because it gets you there faster. The side of it that can be frustrating for a developer is that if you made a change somehow to that URL, people's computers wouldn't necessarily make that update directly because it's saving that information. So That is something called caching, which can be a challenge for developers. But anyway, circling back to the idea that the location ultimately as part of the request is a URL. The second part of the URL is the action. The action describes the type of request that we're going to make. And as a developer, it's your job to figure that out. So the action is the type of request. And for that, I'm going to switch over to the next page here. Maybe let's go this way so that we can talk about the action in a little more detail. So generally speaking, there are 4 types of actions that we would want to achieve with our code. We would want to be able to display content. We'd want to be able to create content. We'd want to be able to edit content and delete. And this is kind of a philosophy of thinking about the behaviors that you want to be able to do with your code. Think about even like an array. If you have an array, you want to be able to print out that array. You want to be able to print out specific pieces of that array. You want to be able to update specific pieces of that array, to be able to take pieces of data and change it. You want to be able to remove that content altogether or to add more content. And so as a developer, we're thinking about this in terms of data manipulation all the time. And so with this, there is a delightful acronym for these things. Because another way of saying display content is read. And another way of saying edit is update. And so when we talk about read, create, update, and delete, we have an acronym, CRUD. And CRUD actions are a way that developers talk about having this complete set of data flow. And as you learn more about CRUD actions and you look at the websites that you interact with, really almost every website is just doing a series of CRUD actions. If you think about Zoom, I can create an account on Zoom. I can look at all the meetings that I have. I can edit those meetings. I can change settings, or I can delete that meeting. I can get onto Lyft and I can create a new ride. I can edit the destination of my ride. I can see where my driver is and what the license plate is, or I could delete that ride. I could cancel it. And so all of our CRUD here maps again back to this action. When we do a request, we are saying where we want to go and which one of these things we're intending to perform. So if I want to make a request that's going to display data, I am going to make a GET request. And if I'm going to make a request that's going to create data, I'm going to make a post request. I think of it as like a post on social media, right? You're making new content that then is stored by that application. If I'm going to update content, there's actually 2 different types of requests that I can make. One is a put and one is a patch. A put request is going to replace the entire existence of that particular data with something else. A patch request is just going to edit a single piece of it. And finally, I can make a delete request. And so while we have our CRUD, that is let's do this. The CRUD is more of a developer philosophy. the requests that we make are our HTTP verbs. And these are the type of request. So knowing what CRUD stands for, read, create, update, and delete, will help you in your vocabulary when we're talking about these terms. And then knowing your HTTP verbs and which action they correspond to is going to make your life as a full stack developer much easier. When we talk about making a GET request, you know what that means. All right. So we're making a request, and we have to know where we're going in the form of our URL, and we have to know what type of request we're making. Then we go find our happy server. Our server contains the information that we're wanting, and we come back with a response. So response, again, has two parts. We've got a status, and we've got a payload. So let's break those down. On the response, we have status first. So status is a code. And there are 5 different levels of status codes that you can have. You can have things that fall in a 100 category, 200, 300, 400, or 500. And to show you this in a little bit more of a fun way, I'm going to switch my screen share for just a moment. Because I can tell you what they all stand for, and it is important to know, but it will be much more fun to know what they stand for while we look at pictures of cats. So status codes come in these 5 different categories. The first type of response that we could get is something that starts with a 100. So 100, 101, 102 is a status code that responds for something informational. There's only a couple of them because this is not a super common status code. The next level, something in the 200s, is good. This is what we're looking for. This is a status code of success, that our request and response cycle did what we expected it to do. .300s, anything that falls in the 300 category is a redirect. So basically the thing that you're looking for isn't here anymore, or the request was sent to the wrong place. Next up, we've got 400 level. 400 level is called a client-side error, which basically means that when we're talking about our request and response cycle, it means something was wrong with the request. So something coming from the client or your personal computer didn't work. This is probably one that you're familiar with, seeing a 404 error. A 404 is kind of a generic catch-all of something went wrong about the request. This is a really common type of error because basically this is a user error. something that the user might have done incorrectly. And so there are many, many different ways that this could go wrong. So there's a lot of 400 level error codes. So just a quick funny side note, this 418 is actually a joke. It was an April Fool's Day joke in the late 90s. And somebody decided to make a protocol for a coffee pot. And the coffee pot protocol was going to accept requests for this very specific thing that would be a need for a coffee pot, documents over the internet for controlling and monitoring and diagnosing the coffee pot. So anyway, the error is that any attempt to brew tea should result in a 418. And it was a just weird, nerdy April Fool's joke that got caught up on the internet. And a couple years ago, people were like, well, you know what, like 400, there are a lot of 400 level errors and they are important. And this is kind of taking up space. That's just, there is this weird internet Easter egg. And so they're like, we should just get rid of it and actually use it for something else. And there was this teenager from the UK who mounted a defense of the 418 and got on Reddit, got people super riled up, and everyone made a big stink about it. And he protected and saved the 418. So it's still the Easter egg of the internet. All right, and finally, our last one is a 500 level status code, which means that there's an error on the response. So something about the server could not process the information. There we go. And while this is just mostly for fun, the status codes are really important because we can think of status codes as kind of like a conditional statement. When you as a developer are working with this request and response cycle, you are stepping outside of basically what you have control over. You don't have control over exactly how the user uses your application, and you don't necessarily have control over how the server is handling the information that you're storing on it. Servers go down, things happen. And so you need your application to still respond appropriately, even when things are outside of your control. So if you get a response code that says, hey, 200, everything's good, go ahead and load your page. If you get a response that says it's a 400, you got to do something about it. And that's where what we call coding for the unhappy path comes into play. I have to create pages that my user can see, but what if my user does something where they make a bad request? So if I go to GitHub and I type in a URL that doesn't exist, I typed in just a bunch of gibberish into the browser, I get back this page, which some of you may have seen before. Sometimes bad links will get you here. And this, with all the cute little animation, somebody coded that. Someone spent the time to create this, and specifically for when something goes wrong. But the important thing here is that the page doesn't look broken to me as a user. I'm not just seeing a blank page and wondering what happened. I am seeing information that says, hey, something went wrong. Here's a bunch of ways to get back on track. Here's your menu bar. Here's a search bar. Here's some links you can click on that may get you to where you need to be. Another fun one is Slack has a really cool 404 page. Again, someone created all of this fun animation. You can hover over the little creatures and scroll around with your mouse. And this was all, again, when something goes wrong. But note that we still have menu bars, places that we can get back on track. And so this is why 400, or I guess status codes in general, are really important to a user, because you're still responsible for that action, even if the action is an error. All right, switch back. Okay, so 100, we have informational. 200, all good. 300s are redirect. 400, client side error, or another way of saying that is that the request was bad. 500 is a server side error. Or another way of saying that is that the response was bad. And when you create code to respond to errors versus codes that are good, it's called coding for the unhappy path. When things don't go the way you expect. Cool. All right. So request response, we break that down into the request has a location and an action. Those actions describe the type of request. The response has a status, and then finally a payload. So this whole thing is HTTP, which stands for Hypertext Transfer Protocol. And this is basically a set of rules that are put into place to try and make these requests and responses more consistent. When the internet was young, people kind of went at it however they could, however they were able to, but eventually it got to a point where it made sense to try and put some order around this. Let's all make requests in a similar way so that we can create a uniform and consistent approach to this process. So that being said, the payload of Hypertext Transfer Protocol is Hypertext Markup Language, HTML. And what's inside our HTML can be two things. Right, another page here. So our payload. The payload of the Hypertext Transfer Protocol is HTML, Hypertext Markup Language. So you've all worked with HTML, right? We get tags with content. And this creates a view. That is one thing that can be wrapped up inside of this HTML, is that we can have tags that create a user view. So that's one thing. The other thing that can be inside of our HTML is not tags, but data. Because when you're creating a full stack application, you're not only dealing with what the user sees, but you're also dealing with content, right? When we're making requests to, if you're making a post request where your user is, say, posting something on social media or submitting a form, you are taking information from the user, adding it to your database, and then your user should be able to see and interact with that information. All of that is not a view. What the user submits is going to be data. And so when we talk about like back-end development, really we're talking about what do we do with that data? Where does it live? How is it stored? And how is it retrieved? And that data has to be passed around on the internet. And it gets passed in the same way that HTML tags that create a view does. It still goes through our request and response cycle. And so when we're passing around data, we talk about JSON. So JSON stands for JavaScript Object Notation. And even though it has the word JavaScript in it, it's not just related to JavaScript. JSON was the kind of the data language that was adopted more or less universally by this particular protocol. It's modeled after a particular version of JavaScript and the object syntax that was the current version at that time. So when you look at JSON, it's going to look a little bit different from what we see now because JavaScript has continued to progress and move forward in their versions, whereas JSON, this particular data structure has stayed the same because it's bigger than just JavaScript. So we're going to look at some JSON here in just a second, but I just wanted to make sure that we are talking about or have covered the idea that when you get your payload back from this request and response cycle, sometimes it's a user view, but sometimes it's just raw data that then supports that user view. All right. Any questions on request response or the vocabulary that we covered? All right, let's look at some JSON. When we talk about making a request and response and getting back JSON, basically that means that we are interacting with an API. An API is a website whose job it is to deliver data. Web APIs can often be incorporated into the back end of an application. If you create a user view and you need data to support that, what you're supporting with could be an API that you built. That could be where everything is stored. Or you could have a user view and you want to support it with data that already exists on the internet. You don't have to create things from scratch if somebody else has already put it out there. So if I wanted to create a website using data from NASA, I could make a request to NASA's server, get a response, and then use that data. And so I would be making a request and response to NASA's API, which is a website that returns data. Not all APIs are created equally. If you're dealing with one that just already exists on the internet, some of them have great documentation, some of them have terrible documentation, but a really cool thing about the internet is that there's a lot of data just out there and people are willing to share. And so what's being laid out here is how I can make a request, what I need in my website. And so here is a URL, right? So the location where this particular data lives. And I'm going to make a GET request to this particular location. A GET request is just going to return me static content. And in this case, what it returns to me is JSON. And this is a hugely ginormous, overwhelmingly big data set. But let's break this down. Let's do this. I'm going to pull up text editor. So I just ran a linter over this that's going to format it in a way that's more readable for us. Same data set, but all of a sudden this becomes, first of all, it's a little bit easier to read, of course, than just having data packed together with no spaces whatsoever. But look at this. We've got something that starts with a bracket and has a bunch of key value pairs inside of it. That's something that we're actually pretty familiar with. So I will tell you that the closing bracket to this one is all the way at the very bottom of this data set. But inside, we can start to look at what's happening here. So there is a thing called photos, and its value is an array. And I will also tell you that the array closing bracket sits all the way at the bottom. This entire object has one key and one value, even though it is something like 5,000 lines long. So one key, one value. But let's look inside the value. Inside the value is an array. And inside the array, this closing bracket right here closes down here. And so we've got one single object that now is still large, but only takes up about 19 lines. So going from 5,000 to 19 is pretty nice. And looking inside here, we can see that there's a key called ID that has a number attached to it, a key called soul with a number. Camera is a nested object with some just basic key value pairs that has numbers and strings. Image source is just a string. A couple more just basic key value pairs. That object ends here. And if we look at the next object, the pattern is exactly the same. So we took this, which makes my brain hurt to even think about, and broke it down to repeated 19-ish lines of code that is very digestible. You all know how to interact with data such as this. You can parse into objects with dot notation. You could iterate over an array because this is an array of objects. This all becomes very available. And that's what developers do. You package up data sets and then you break into them and pull meaningful information. But if you are making a request and the response that you get back is this, you're working with an API and what you're getting back is JSON. So this object notation does feel very familiar. The difference is right here. When we created key value pairs, the key was a symbol, meaning it didn't have quotations around it. And these keys are strings. And that is the big difference between what we work on as JavaScript objects and JSON, because this JSON was adopted at a point when JavaScript hadn't yet developed the idea of symbols. Symbols are a little bit more of a modern version of JavaScript that create this unique identifiers inside of a key value pair. So this is just a string, but it's serving the exact same purpose. And if you can move past that there's quotations around it, knowing that it's still just a key, this all becomes very, very familiar, which is pretty cool. So that's it. Internet from a developer standpoint is a series of request responses. We got to know where we're going and we got to know what type of request we're making. Knowing your HTTP verbs will help you out immensely next week. We get a response back, status code, and payload. Payload comes in two flavors. Everything is wrapped inside of HTML. What we get back from this, if I inspect the page here, come down here. Come here. See, HTML. It's got a head, it's got a body. It's just that what's inside the body is JSON. So always comes back and wrapped in HTML, but it's either going to deliver a view or it's going to deliver data. So it's going to deliver tags or it's going to deliver JSON. And JSON is just a slightly earlier version of JavaScript object notation, but it's the language that's bigger, or it's the language of data that spreads across more languages than just JavaScript. It's sort of the data language of the internet. All right. Well, I will send over the beautiful drawings that I created so you can enjoy my artwork forever. I'll put them into your Google Drive. Yeah, that's what I got.